Hello there and welcome. You're watching Dreamy Science, where we slow things down and zoom way out. Tonight's topic is a strange one, because we're not just talking about black holes or the Big Bang. We're asking if the universe itself is on repeat. What if everything we know, this moment, this galaxy, this life, has happened before? Not just once, but forever, looping again and again? And if the universe loops, would you even know? Now here's the part I'd love to hear from you. If the universe restarted tomorrow, and you had no memory of this one, would it matter to you? Would it make today feel more important, or less? Drop your answer in the comments. I read them all. And now settle in. Let's unpack what it really means if the universe loops forever. Hello there and welcome. You're watching Dreamy Science, where we slow things down and zoom way out. Tonight's topic is a strange one, because we're not just talking about black holes or the Big Bang. We're asking if the universe itself is on repeat. What if everything we know, this moment, this galaxy, this life, has happened before? Not just once, but forever, looping again and again? And if the universe loops, would you even know? Now here's the part I'd love to hear from you. If the universe restarted tomorrow, and you had no memory of this one, would it matter to you? Would it make today feel more important, or less? Drop your answer in the comments. I read them all. And now settle in. Let's unpack what it really means if the universe loops forever. If the universe truly loops, we have to ask one of the most basic questions. How would time behave inside such a system? This isn't just a curiosity, it's central to the whole idea. Time is what defines a sequence of events. But in a looping universe, that sequence either resets, reverses, or folds in on itself. So does time move forward forever, or does it somehow bend back to the start? Physicists often talk about the arrow of time, the idea that time has a preferred direction from past to future. This arrow isn't arbitrary. It's linked to something very real, entropy. Entropy is a measure of disorder, and the second law of thermodynamics tells us it always increases in a closed system. A glass shatters, but the shards never leap back into form. A hot cup of tea cools down, but doesn't spontaneously reheat. Entropy rises, and that rise gives time its direction. So in a looping universe, we need to explain what happens to entropy at the turnaround point. Does it reset? Reverse? Does the second law break down? If time loops but entropy doesn't, then every loop just gets messier and messier. A cosmic game of telephone degrading with each round. Eventually, the loop would fall apart. But that's not what many models suggest. In some cyclic cosmologies, like those involving a big bounce, entropy is preserved but diluted. Imagine the universe contracts to a small but non-zero volume, and then rebounds. All the entropy from the previous cycle is still there, but stretched out over a new phase of expansion. The arrow of time keeps pointing forward, even as the universe goes through cycles. That would mean that while the universe loops in structure, time itself never truly reverses. It just resets its stage. But other ideas go further. They suggest that time might reverse during the contraction phase. As the universe collapses, entropy might decrease, and the arrow of time could flip. From the inside, it would still feel like time was moving forward. But from a larger perspective, the direction of time has changed. This is controversial because a reversal of entropy defies everything we observe. But in extreme conditions, like a collapsing universe heading toward a bounce, the normal rules might not apply. There's also the possibility that time doesn't exist as a fundamental thing at all. In some approaches to quantum gravity, time is not a built-in part of the equations. Instead, it's something that emerges from the way events relate to each other. In these views, a universe that loops isn't looping through time, it's cycling through configurations. Time is just how we interpret the progression from one configuration to another. So in that sense, a looping universe isn't moving in time. It's just arranged in a circle, and we're riding along its edge. This might sound abstract, but it leads to an important idea. If time is emergent, then loops in the universe don't have to involve clocks resetting or calendars repeating. They could just be patterns in the fabric of reality that return to a similar state, like a heartbeat or a wave. There's no need for a mystical rewind button. just a deep, underlying structure that repeats. And now we come to a more personal question. If the universe loops, would your life, your memories, your choices, all of it, happen again? Or would the loop be different each time? This gets into the question of determinism. If the laws of physics are completely deterministic, meaning every outcome follows unavoidably from previous conditions, then in theory, a perfectly identical universe would produce the same you, making the same decisions every time. But quantum mechanics complicates that. At the smallest scales, events aren't deterministic. They're probabilistic. An atom might decay now or a second later with no cause we can trace. These tiny fluctuations would ripple out into larger effects, especially over billions of years. So even if the universe loops in structure, it doesn't guarantee an identical replay. Each loop could be familiar, stars, galaxies, perhaps even life, but different in its details. In that way, a looping universe wouldn't trap you in an eternal rerun. It would be more like a song played by improvisational musicians. Same key, same rhythm, but each performance is its own. Coming up next, we'll explore whether there's any actual evidence we can detect, signals or patterns that would prove if we've been through this cosmic loop before. Now let's move from theory to evidence. It's one thing to imagine the universe looping, but quite another to prove it. So, what signs would a cyclic cosmos leave behind? Are there fingerprints in the sky or signals in the data that could point us to a cosmic rerun? The most obvious place to look is the cosmic microwave background, the oldest light we can observe. This light comes from around 380,000 years after the Big Bang, and it's been traveling across the universe ever since. It's like a baby photo of the cosmos. And hidden in that photo, some physicists believe, are signs of previous cycles. In particular, physicist Roger Penrose has proposed that tiny, low-variance circular patterns in the cosmic microwave background, which he calls Hawking points, could be echoes from a past universe. In his conformal cyclic cosmology, CCC, each universe ends in a vast, smooth state, which then maps mathematically onto the beginning of the next. If that's true, remnants of black holes from the previous universe might still leave circular imprints in the sky. But not everyone agrees. The patterns Penrose points to could be statistical noise, random fluctuations with no deeper meaning. Cosmology is notoriously difficult to confirm through direct evidence. We only get one universe to observe, and even that is limited by what light has had time to reach us. So while the idea of finding scars from a past cosmos is compelling, it's still hotly debated. Another possibility lies in the large-scale structure of the universe, how galaxies and clusters are arranged. If there were leftover imprints from a previous cycle, perhaps we'd see symmetry or unusual alignments. But so far, no such patterns have been confirmed. The universe looks mostly random and isotropic, the same in every direction, which matches the standard Big Bang model quite well. Still, that doesn't rule out loops. If the universe stretches or resets in such a way that it erases memory of the previous cycle, like a cosmic hard reset, then we might never see direct evidence. But some physicists think there could be indirect clues in the behavior of dark energy or dark matter. Dark energy is the mysterious force driving the accelerated expansion of the universe. In some cyclic models, this expansion slows, reverses, and leads to a new Big Bang. The dynamics of dark energy, how it changes over time, could help confirm or rule out those models. But again, our measurements aren't precise enough yet. So right now, the evidence for a looping universe is thin. Not because the idea is wrong, but because we may not yet have the tools to test it. Science often moves in steps, first the theory, then the predictions, and finally the observations. We're somewhere between steps 1 and 2. The math works out in some cases, but the telescope hasn't caught up yet. And yet, there's something poetic about this search. We're looking at light that's over 13 billion years old, hoping to catch a glimpse of something even older, maybe even something eternal. Whether or not we ever confirm it, the very act of looking pushes our understanding forward. Coming up next, what would it mean for you if the universe loops? How does this idea affect our place in the cosmos? And what does it say about the meaning of it all? If the universe is indeed cyclic, endlessly looping through birth, evolution, and collapse, it raises some deep philosophical implications. What would this mean for our sense of purpose, our urgency, and even our individuality? For some, the idea of a repeating universe sounds exhausting, like a cosmic Groundhog Day. But for others, it's oddly comforting. If everything comes back around, then nothing is truly lost. Every star reborn, every moment recycled. Let's bring it down to a personal level. Would your life matter more or less if you knew it would happen again? Does uniqueness give value to a moment, or does its recurrence give it weight? There's a duality here. On one hand, if this is your one and only shot at existence, that could make every second feel sacred. On the other, if life returns in cycles, even altered ones, perhaps you're part of something enduring, woven into a pattern that never ends. Some ancient philosophies hinted at this long before modern physics. Hinduism and Buddhism, for instance, both describe time as cyclic, a wheel of creation and destruction. The idea of samsara, of reincarnation and endless rebirth, maps surprisingly well onto certain cosmological models. Thousands of years before relativity or quantum theory, thinkers were already imagining the universe as a loop. In that sense, science might just be catching up with myth. Or maybe it's myth catching up with math. Either way, the resonance is striking. And it invites a kind of humility. We're not necessarily at the center of a grand, linear story. We might just be passengers on an endless ride, significant but not unique. Important but not final. Of course, none of this is proven. The looping universe is still just a possibility, one of many models competing for our attention. But thinking about it reshapes our view of existence. It encourages us to stop seeing the universe as a straight line with a beginning and an end. Instead, it becomes a rhythm, a breath, a wave. Always moving, always returning. And maybe that's enough. Even if the loop can't be confirmed, it's a reminder that reality might be bigger and stranger than we think. And within that mystery, there's space for awe, for wonder, and for meaning that doesn't depend on being first or last. Just here, now, part of the flow. 3, but here's one final angle we haven't yet explored. How might a looping universe affect the future of scientific discovery itself? If reality is truly cyclic, and if civilizations can rise again and again, perhaps some knowledge is also fated to repeat. Could science itself be on a loop? Reinventing the same theories, discovering the same truths over and over? Or would each cycle bring entirely new frameworks, shaped by different cosmic conditions? Maybe the constants of physics shift just slightly in each loop, leading to new laws, new forms of matter, even new ideas of consciousness. It's a profound thought that not only stars and galaxies, but questions and insights might echo across eternity. We may not be the first to wonder if the universe loops forever, and we might not be the last. And if that's true, then even asking this question here now is part of something much larger. A curiosity that spans cycles. A moment that ripples forward, and maybe backward too. Thanks for being part of this loop. Let's step back and ask a practical question. If the universe is looping, and let's say it has done so forever, what does that say about the limits of existence? Not just philosophical ones, but actual limits baked into physics. Could everything that can happen eventually must happen? And not just once, but infinitely many times? This brings us to something called Poincare recurrence, a mathematical theorem from the late 1800s. It applies to closed systems like the entire universe, assuming it's finite in energy and volume. In simple terms, it says that after a long enough time, a system will return arbitrarily close to its original state. It won't be exact, but it'll be close. So if the universe lasts forever and isn't infinite in complexity, it should cycle through the same or very similar configurations, again and again. Now combine this with quantum mechanics. At the smallest level, the universe isn't continuous, it's granular, like pixels on a screen. That means there's a finite number of ways matter and energy can arrange themselves in any region. It's a ridiculously large number, but not infinite. So if time goes on forever or loops, those configurations should repeat. Not just galaxies or life, but moments, thoughts, maybe even you. This leads to a mind-bending implication. That not only could this moment happen again, but it has happened. And will again. an infinite number of times. Some versions almost identical, others wildly different. In one loop, you're reading the script. In another, you're writing it. In another, you're a tree. That's not science fiction, that's what the math could imply if certain assumptions hold. The Poincaré recurrence time is staggeringly long, vastly longer than the age of the universe, but in a truly eternal or cyclic cosmos, those timescales don't matter. Infinity has room for everything, over and over. Now this is where things get weirdly personal. Because if this moment comes back again and again, does it lose its meaning or gain some? If your choices, your feelings, your very thoughts are part of a pattern that repeats, does that make them mechanical or part of something deeper? Some physicists and philosophers push back here. They say recurrence is a mathematical idea, but reality is Messier. Maybe quantum uncertainty adds so much chaos that no moment can ever repeat. Or maybe the universe is open, not closed, expanding forever with no chance of return. Or maybe entropy builds and builds, making each loop more diluted, more forgetful, less structured. But the idea persists, not just in science but in ancient thought. Nietzsche spoke of eternal recurrence, the idea that every action, every breath, might return infinitely. He framed it not as a theory, but as a test. Would you live differently if you knew your life would repeat forever? And here's where we land. In the space between numbers and meaning. The science tells us recurrence is possible. The philosophy asks us what to do with that knowledge. Would you change your day if you knew it might loop back? Would you savor it more or care less? But let's talk scale for a moment. Cosmic scale. Because if the universe is looping, you might wonder, how big is a loop? How long does it take? Are we talking thousands of years? Billions? Or something beyond even numbers? In most cyclic models, the loop isn't a brief flicker. It's colossal. A full cycle, from one big bang to the next, could take trillions of years. That's longer than stars live, longer than galaxies as we know them can hold shape. It's a time span that melts our usual frames of reference. But oddly, that's part of the point. These models stretch time to the edge of imagination because they have to, resetting the universe, erasing entropy, dissolving structures, smoothing out the chaos. Isn't quick work. The laws of thermodynamics demand a cost, and the universe pays that price in time. Some physicists suggest that after trillions of years, even black holes will evaporate via Hawking radiation, leaving behind an eerily empty cosmos. No matter, no light, just a cold, flat vacuum. And then maybe the conditions are right for a new beginning, a fresh burst, another cycle. Others argue that the loop happens not in time but in form, that the structure of the universe repeats without needing a literal clock to track it. Think of the Mandelbrot set, a shape that repeats at every scale, infinitely detailed yet bounded. What if reality itself behaves like that? Each cycle unique in its details but patterned in structure. This brings us to a wild implication. If cycles are unimaginably long, and if memory and structure are erased each time, how could we ever detect them? How would we know we're not the 10,000th iteration of this cosmos? Maybe we wouldn't, and maybe that's the strangest part of all. A reality so vast, so old, so repetitive that it becomes indistinguishable from a one-time event. From inside the loop, you can't see the edges. Every loop feels like the first, or the only.